Today we will continue with the subplate, the one that we have designed in the last video. We will be inserting some screws and pins using the master card component option. We can actually do this because we have chosen hybrid design when we started with this part. Hybrid design allows us to treat this as an assembly and actually being able to place other components into it. So we open Mastercard. I will open this and make it bigger so you can see. First I want to insert the DIN 797 dowel pins. Choose here 6mm, 60mm length. Compress it, make sure it's 3D step, download it. Takes a while. Once it's there, we will use the assembly drop down and choose joint. Move to this area here, choose the lower point in the middle here. And move to the actual hole we want to place it in. So we go down here, choose here, and it will be placed on this position. We can copy this part. And again, we will use joint. Select this area again and place it in the hole. After these two dowel pins have been placed, we will be inserting some screws. Insert Mastercard. Open this, make it bigger so you can actually see. We are looking for screws. We are looking for metric M4, 16mm in length. Socket head screw. Choose the first one that is matching the description we want. 3D step again, download. Wait till it's here. It's here now. So now we go and use the joint function again. Choose this surface and the middle point. On the other side the same, we select this surface and then click on the middle point, and this screw is also placed. I will copy this screw, repeat the process of placing it with joint, but this screw will now face the other direction. If you remember, I told you that these inner holes are for us to be able to mill the subplate from both sides. So they are basically temporary fixing solutions. And instead of placing all the other screws one by one, we can use the rectangular pattern function. You select the axis, so then you can drag it in which direction you want. We want to have 2 units and 300mm apart. And the second direction would be this one, 2 units again, but this time 100. We can also use the same rectangular pattern for the inner ones. So I select the correct one, this one here. Choose rectangular pattern again, the axis. Move it 100 and 2 units in this direction, and in the other direction the same, 2 pieces and 100. This looks fine so far, so we have placed all the auxiliary parts that we need for the manufacturing process. What I will be doing next is add a plane, so offset plane from the lower surface and move it upwards 100. Then we will place a sketch here and use the project, the origin. Press OK. This point will be actually our first work coordinate system origin, so basically the 0 point for the manufacturing process. We are now ready for the manufacture process. We can go up here to the drop-down menu, choose manufacture, which will open our manufacture environment. These components that we have here should be turned on and off in terms of visibility, and what helps us here to do this automatically is this option. I always select all of these checkboxes, makes it super easy and simple to actually see what is actively in use. Before we go much deeper, we should talk about machine simulation file and also tool library file. Both can be found on the MiWiCNC website, and I think it's best we just go together there right now so you can see how to navigate inside the website. Welcome to the MiWiCNC website, the backbone of what I'm trying to build for the community here. Under software and CAM setup, you will find the machine simulation, importing the machine models. For the project we are doing now, we want to use the 3-axis version. You can download the file and then follow the step-by-step guide that is provided with screenshots, with pointers and videos. For the tool library, we go to the left here. There is also the importing tool library option, and in this tool library there are all the tools that I have tested on the Artisan and found cutting parameters for. This tool library especially will be extended over time, so maybe once in a while check it if there are any new tools included. We are back in Fusion and can start creating the first setup. I will cancel this so you can see the process from the beginning. So we select the machine. It will be the 3-axis one, the one you just downloaded before. Let's continue. The operation type milling is okay. Orientation is not okay because set is looking downwards. We can use this option to manually set it. We select the surface and now set is facing upwards. Axis also looking correct. Origin, we select a point, this one. For the model, Fusion thinks this whole model with all the components is the thing we want to mill, but we don't want this. We want this to be the model to be milled. And fixtures, we don't have any for this first setup. Let's go to the next tab, the stock material tab. I will set the side offset to 2. So this will give us a total of 122 and 384 millimeters. Meaning if you didn't place the plate super precisely, we still have some clearance, so we will not have collisions happening. The same goes for the stock top offset. Right now the stock height is 14, my raw material is 15. I will set it so the raw material will be viewed as being 60 millimeters, just to have these imperfections both in the machine and also in the raw material to not cause any problems. Lastly, I want to position this part, so I will select here select point. I will choose reference point, for example this hole here, which should match then also on the CNC board on the corresponding hole here. Place it, and we can, if we want, to open the preview machine and move around with the sliders and see how this would look like later on. This is totally optional, but maybe open it once to familiarize yourself with this option. So we have done everything, set it up, and from here on we can create our first operations. The first operation we will be placing is a 2D pocket operation. We will select our tool from our tool library. It will be a 4mm end mill with 17mm flute length. On the presets, we set aluminium full engagement, and then we go step by step. Machining type is okay, we leave it how it is. Geometry, here we need to select the geometry we want to mill now. So I will select these contours here from our fixing holes and the last one here. I will change to the next step, the height tab. I will change the retract height to 70 and the top height to 1 millimeter above the stock top, just to give a little bit more clearance. At the base step, we will activate multiple depths, and stock to leave we will deactivate. Lastly, in the last step, in the linking depth, I want to adapt the ramp clearance height to 0.1 millimeter. We press OK, and the first operation is generated. The next geometry we want to mill are small holes, so we can use another function, the bore function, a more efficient function to cut small holes. The first step can stay how it is, the second one also. On the geometry tab, we will choose our holes. So the first one here, second one, the third one, and the last one here. On the height tab, we will set the retract height to 70, top height to 0.1, and we want to cut all the way through, so -1 for the bottom height. For bases, I uncheck this checkbox and manually override the pitch to 0.1 millimeter. For linking, I like to activate lead to center. And this operation is also done. Let's see what we have created so far. To better visualize this, I will make a section analysis and shift this to the holes here and make the viewpoint to the front. We can select our operations so we can see where we cut. The second one cuts all the way through. We can also simulate this. Select both and right click simulate. And now you can click on play to run the simulation. As you can see, it cuts from the top the 2D pocket operation. When this one is done on all 4 holes, the second operation will kick in, cutting the small holes with the bore function, all the way through how we intended to. We can also view this simulation because we have loaded the machine together with the machine. So you just select right click simulate with machine. I will remove the section analysis, choose here viewpoint machine, and when you play here you basically see how the machine will produce this part. You can see after it finished the hole, it moving up to the next hole. This big movement upwards is the 70 millimeters that we set. Helps to better visualize what will be going on your machine later. I think in the beginning it's very nice to use this function so you know ahead of time what will happen. We are ready to generate the first G-code. We will head one more time to the website and get our post-processor. We will be using the first one. This is the 3-axis version. Again, you follow the step-by-step guide to install it on your system. Back in Fusion, let's generate the first G-code. So we select both of these operations, press on G-code generation, open our post, the Snapmaker .cps. Put a meaningful name. I will name it subplate underline setup 1 and the A section. Press post. Takes a while to generate. We can view the CNC code, and up there it will show you where this G code is saved at. For my case, this is the path it is saved to. For the next step, any pointed tool will do. I will mount it on the machine. I will make the machine go home first, and from this point on I will jog to the middle of the cutting board. So all the way down till we are near, and you just try to move the tip directly over the center point of your CNC board. We will zero X and Y, but also remember the machine coordinates we have here. I like to place them on the controller for later reference. Now we will go ahead and mount our end mill, the 4mm end mill with the 17mm flute length. When you mount this tool, make sure that it sticks a little bit over the top here, and make sure that you have at least 17mm. You should easily have more than that. Now we go into the Lumen software under Workspace. We connect with our machine, and now down on the left here in the console we can move to 0. So we go G0, X0, Y0. This will make the machine move to this position, and from here on I just jog down again till I'm close. And now I use feeler gouges. I will use the 0.1 and the 1mm one. The 1mm one just to come close to it till I know now I'm under 1mm away. So I go down and down till I see, okay, now this doesn't fit anymore. I switch back to the smaller one, set my step to 0.1 and go all the way down till this doesn't fit anymore. From this point on we move 100mm up. In this position we will zero the X, the Y and the Z. Now it's time to place our raw material. In this case I'm using a 120mm times 382, maybe 384mm long piece of aluminium plate, and fix it like you see here in the image. Not every aluminium is suited for milling. I would recommend to check my website for recommended alloys, and also the sourcing material list. Here you can find where I source my aluminium. Again, we are using the console to go to 0, this time also with the Z. So we move to the place we have set our 0 point to, and from here on we can start our CNC file, normally running over the Artisan controller. It will start with our first operation. I will occasionally speed up the footage and slow down for important transitions. So now here we can see the first entry of the 2D bucket operation. I will speed this up to the last hole. After this operation is done, we will continue with the second operation, which are the small holes, the bore function if you remember. It will cut into the metal again, working its way downwards. And here is fast forward to the last hole, and then it will move up and finish this cycle. What we have here are the holes that we just created. I just clean it real quick with a vacuum cleaner. Now I will keep the fixtures still in place and use the screws to mount it on the CNC board. Lastly, for the next step, the blade is now secured by the screws. I will unfix the Snapmaker Artisan fixtures and remove them for the next setup. We are back in Fusion and preparing the next setup. The first one is done. So we switch back to design. I want to create a plane again. This time I will take the upper surface and move it upwards 100 again. Now we do a sketch on it and go under Create, project, include project, the origin again. Next step is to add another sketch on the surface here, and I want to draw two diagonals starting from here downwards there, and another one from here downwards there. This sketch will help us to do the next operation, which will be a tracing operation. I will show you in a minute. So we will switch back to manufacture. Choose, first of all, we need to create the setup. So we create setup, a new setup in this case. We need to set the modular orientation again. Clicking on this surface, select the point, this time the upper point, the point we just created. Model is still the one we have selected, and now we have fixtures. So we select the 4 screws here. So one is here, there is another one here and here. And I will set the radial and axial clearance to 2 millimeters. At the stock tab, we go relative size box, side offset again 2 millimeters, and stock top offset 0.3. It will make sense with the following operations we do. This will allow us to just cut what we need. I don't want you to mill down 5 millimeters for nothing. I just want to cut away what is really needed to have it flat. Here you can see me just placing the blade again where it should be. And now the setup is ready. And we can start with the next operations. So as I have told you before, we will use the trace function first. So we go here, trace. This can stay how it is. It's our selected tool. Geometry will be now these two diagonals. On the height tab, I will leave it as it is. And passes, the only thing I want to change is stock to leave. And I want to leave 0.3 millimeters. I want basically this trace to be just skimming over the top of the stock. For linking, I will add an extra big lead in and lead out. We'll set this to 4 millimeter. So let me finish this one and zoom into this lead in and lead out. You can see the end mill is moving inwards in a radius and also leaving the material in a radius. Coming up again with the radius and outside again with the radius. This operation is very short and helps us to find the top of our surface. So we can repeat this short function or this short operation and find precisely our top without being too deep into the material with our first operations. The next operation will be a face operation. Again, tool is set, we don't need to change something, also not in the tool orientation. Geometry is also well set, we don't need to change anything. The height tab, important, we set the bottom height to 0.3, so the same value as before with the trace, just want it skimming over the top. For passes, I want to change the direction to climb. And let me have a look at the linking tab. Everything looks fine here. We can press OK. We will also simulate this, show you what it's doing. It just skims over the top. It should actually not really take material. It's just making sure that we don't have any bumps or material being higher than this reference. It's time for the next G-code. We will only select the trace and post the G-code again select your post processor and we name it setup 2 underline A, so we remember it's this first part that we want to do on the machine. Similar like before, we use the same function in the console to go to 0. We can do this because we are far enough away, jog down, and now we find on the aluminum plate the 0 point again with our filler gouges. Once we have it, important, we will move up by 100 plus an additional 2 millimeters. 2 millimeters because I'm not sure how your raw material is, I'm not sure how precise your machine is, how precise your CNC board is, and as you can see now, I just run carefully with this 2 millimeters offset this operation, and I can see I'm scratching nothing basically. I repeat this process again and go a little bit more down. I would recommend going down 0.2 millimeter steps for beginners. If you know what you are doing and if you know how precise your machine is and also your raw material, you can also go deeper steps. In this example, you can see I'm actually now cutting into the material. So I have found the highest spot, which seems to be on the left down corner. You can see it here, here's nothing, but here and also on the corner on the top a little bit, there is first cutting action. It's time for the next G-code again. Now we select the face operation, export it again, name it setup 2 underline P, and go with it to the machine. Again we go to 0, the 0 point we have been before, and now we just go from right to left and face this. And you can see in the video that the left corner is the one that we just skim now. I will repeat this process over and over again. Always go to my 0 and go 0.2 millimeters down. I have removed this much material in 2 goes, and I was wondering how much clearance I still have on the lowest point here on the side. I have measured it with the feeler gouge and have seen that I have less than 0.3 millimeters there. So knowing that my operations will take away an additional 0.3 millimeters, I knew I could stop and didn't need to run this phase operation again. We are back in Fusion and will be continuing our setup 2. We will add another operation from this 3D tab, the pocket clearing operation. Tool is OK. On the geometry tab we will change machining boundary to none, and we will add another surface group. We will add an avoidance surface group with radial 5 millimeters. To click here we need to make the sketches invisible. Now I can click these holes, select these holes. I select them because I don't want the pocket clearing to cut here. I want the pocket clearing just to cut the top and a little bit from the side. For the heights we set a little bit distance to the stock top, and we choose here model top, and from this on minus 1.5 millimeters. For passes I want to change the stock to leaf to minus 0.5. Might seem a little bit odd, but will make sense later, and the axle stock to leaf 0.1. Linking tab looks OK, so I press OK. The minus 0.5 for radial stock, like I said before, is a little bit odd, but it will make totally sense once we are starting to mill. Basically what I'm trying to do is undercut it. Why I'm doing this is when we flip the part, we want to precisely mill how the part should look like and be able to reference also to the side walls. And if we would cut from both sides on the same specific value, we could have a tiny little like overlap, or like imperfections here. And I want to completely avoid this by just undercutting it. But trust me, it will make sense afterwards. I think we better continue now with the next operations, and later in the milling phase we will have another look on this odd value, and trust me, then it will make sense to you. Next operation we want to do is a flat operation. Tool again looks okay, multi-axis also looks okay, geometry, machining boundary still none. Here we choose machining over holes and pockets. It automatically sets to 8, that's big enough. For heights we set model top to 0, and for bases I want to make it very small to 0.5 to create a very smooth surface for us. Linking looks also okay, and I press OK. This will take a while to generate. The flat operation is done. We already start with the next one, the ramp operation. We will switch to the geometry tab, set the model to a void, and create another surface group. This time we want to actually mill here, so I select these sidewalls here. And the last one here, press OK. For the heights, we will set the model top again, and again this minus 1.5 millimeters down. Bases, 0.2 maximum step down looks okay, and stock to leave, -1. Again, this odd value will make sense later. Links, everything looks fine, so I press OK. I will copy this ramp function and edit it. And this will basically just recut the same path, but I will set it to 0.5 maximum step down, because I'm basically cutting nothing here, but I just want to clean these sidewalls up. Next operation will be a bore function. We will start with the thread holes here. The tool looks fine, like always. For the heights, we will be setting the hole top 0.1 distance and model top -10. I don't want to cut all the way through into the cutting board here, that's why I choose only -10 millimeters. Uncheck this box again and put the pitch to 0.1 millimeters. For the linking, like always, I like to put it lead to center. I will also copy this one, edit it, change nothing, just the pitch to 0.5. It's again just a recut of the same geometry, cleaning it up basically. We have 2 more holes to mill, so we create another bore operation. Select these 2 holes, and for heights, this time we set the 0.1 and the hole bottom at 0 is okay. For bases, uncheck again 0.1 and linking my preferred way of leading to the center. We will also copy this function here and edit it. This will be an important function because we will place the dowel pins inside. So what you see me doing here, the 0.5 we can set again, but we will also check the repeat bases. Here we need a precise fit. So we will try to edge closer and closer to the perfect diameter, so the dowel pins just barely fit in. I will mark this operation by placing adjust in front of it, but for now we just mill it how it is, and later we make the adjustments. We have created a bunch of operations now. Let's mark them and do a quick simulation of it. Let me run you through it. So first we have the pocket function. It will start in the middle, work its way outwards, and it will also start cutting down at the sides, as you can see here. Let's fast forward to the flat operation. You can see it makes very small step overs, creating a very smooth surface for us. This is the ramp function, so it just runs around on the sidewalls. Then we repeat this to clean it up with the second ramp function. And now we are already at the holes. The holes will be cut and recut to clean it up. And with this being done, we are ready to do our next milling part. So let's jump right there and I will guide you through it there. So let's generate the G code. So we want from bucket to all the way down here. Press generate the G code again with our post processor. Name it to setup 2 underline C. Let me also comment the next operations we are doing on the machine. We again go to 0. We will start our CNC file from the Artisan controller. First operation that is started is the bucket function. Will work its way into the material, cutting from inside to outside, basically flattening this area again. It's roughing, and it will transition to the side of the part, cutting first the corners and then running around the stock material. The next transition we have is from the bucket to the flat operation. The flat operation has very small step over, creating a very smooth surface for us. It's finally finished here. The next transition is from the flat operation to the ramp operation. The ramp operation will create our smooth side walls, and we will rerun this ramp again to have it precise and smooth also on the side. Now we continue with the holes. It will work its way downwards, and in the end, the important ones, we will recut the pinholes, and in the next step we need to edge closer and closer to the desired diameter, so we can barely fit in the dowel pins. We want a precise fit here basically. So let's do the thing with edging closer to the diameter we need for the pins to smoothly go into the holes. Under basis there's this option stock to leave, and I recommend to go minus 0.01 millimeter steps, so up to 0.02, 0.03. In my case I needed to go up to 0.05 millimeters for the pins to fit in smoothly. We want small steps here, because if you overdo it, the pins will wiggle inside the holes and this would not be nice. So we will select only this operation. You don't need to do the whole process again. We will select the post processor again, and just for me to remind myself which cycle I'm on right now, I just add the 0 underline 01 for example. So let's start this single operation just for recutting the holes. We will use this operation as we have programmed it before, so it will do a repeat pass. The repeat pass is important because it makes sure that what we milled away is actually milled away, and tool deflection will not cause any deviations. So it's nearly done. Once it's done, I will take a tool. It's a tool to manually deeper holes, just to remove the edges on the top, and then I try to fit in my dowel pin. As you can see here, it's not fitting yet, so I go another cycle with 0.02 or 0.03 and go upwards, upwards, upwards till this will happen. So the pins will go inside, will not wiggle down there, and can be removed by applying some force. Let's continue in Fusion. I want to do one last step, which is chamfering the edges, so deburring basically the edges. We will select an engraver tool with a 90-degree angle. It's set to aluminium, and for geometry we choose this edge here. For passes we will set it to 1.2 millimeters and this to 0. Once we simulate this, these values will make sense and you understand why I set them in this manner. Let's add another operation like this. Now for the holes, we have milled inside the part. I just select this top edges here and we'll change this to 0.2 and the tip offset stays at 1 millimeter. I copy this second one and will just change in the passes step the chamfer width to 0.5. I want to first only cut 0.2 and then cut another part of it in a second go, just to have it being less stressful for the machine and the tool. Let's zoom in here. We see that with the values we have set, we basically still deeper the edge and the tip doesn't touch the part. This is how it should be. For the holes, don't be concerned about these holes here and here. These are just there, shown like this, because we have not set the raw material for this setup to be taken from the steps that have been done before. You can see me changing to the new tool here. Don't forget to let this tool also stick a little bit over the top here. When you mount it, we go to our 0 point, then jog down further, use our feeler gouges again, find this surface. Once it's found, we will move 100 millimeters up, and once we are up here, we zero at this position, load our CNC file, our G-code, and start it. Machine will start running. It will start with this edge here. Let's fast forward this. Then it will transition to the holes. The first round with the 0.2 millimeter chamfer width, and afterwards another one with 0.5 millimeter chamfer width. Now we have a little bit of manual work ahead of us. I will be removing this subplate for us. Take it out of the machine. Now we need a manual thread cutting set for M8 with the matching drill. I'm using a drill press here to just cut all the way through of these M8 holes that we didn't cut all the way through in the machine because I didn't want to cut into the CNC board. Once we have cut through, we will use the thread set, starting with the first of the 3 thread cutters, and basically creating our M8 threads. The M8 threads, it will be shown in the very end of this video what they are for. It's for helping you to remove the subplate once it's mounted on the machine. I'm nearly finished here. This is the last pass. I deeper also the thread holes we just created, And now it's time to continue with the next operations inside Fusion. So we switch to design, and again we need to do some preparation. I start with a plane that we need, -100. We will set or project the origin again there. Press OK. We will create another plane. This other plane will start from this surface here. Exactly the same. 100 mm up. Create a sketch. Project include the origin. Next is another sketch. A sketch for the diagonals, like we did also on the first side of the subplate till here. Finish the sketch. Another sketch need to follow. This sketch will be referenced to the dowel pin holes. So I just make 2 circles here with 6 mm diameter, and I will project include these contours here. These are the dowel pin contours, so I can reference to them. These 2 circles that we draw here will be our geometry that we cut to create the holes in the CNC board where the dowel pins will fit into. So we have everything, and we can switch to the manufacturing environment. Create a setup. Firstly, we will change the origin to this point here. The model is our body here, this one, and stock like before, side offset 2 mm and top offset 0.3 mm. Lastly, let's also position the part in the machine here. Click OK. The next setups are pretty similar, so I copy this setup and rename them to setup 4 and setup 5. While setup 3 is active, we will create a 2D contour operation. I've made the body invisible, so it's easier to select the correct geometry. So make sure the arrow is inwards. And for heights, the top height we change to selected contours. Give a little bit of clearance, like 1 mm, and we go -9 downwards into the CNC board. For ramp, we will change the step down to 0.5, the clearance height to 0.1. So I will copy this one just in case for you. I will mark it to adjust. It could be that, same as with the dowel pins, we need to adjust this diameter, like slowly increasing the diameter to be able to fit the dowel pins in smoothly. In the setup 4, I actually want to adjust the stock height to something more reasonable, like let's say 3 mm, so our stock height is 60 mm, just to have enough distance and clearance to do our bores for fixation. Let's go to setup 4. So we are basically doing the same as in setup 1, so I just copy or duplicate them. the operations from there and edit them and just make a change in the geometry tab. So I don't want these, I want now these here. And I don't need to worry about, do I have the correct tool? Do I have all the other values set correctly? I know that the one that worked before can also be used here. I do the same with the bore function. So I first need to deselect all and then I just select the new geometry. And this is done. So for the setup 5, we need to adapt first the setup a little bit. What we want to have is we want to set the origin to the upper point here. And we also have fixtures in this setup. So it would be these screws here. But besides that, we can reuse the setup as it is. Now we want to add some operations. And again, we have done already a lot of similarities in setup 2. So I will select all the way down before we start with the bores and also the chamfers. Duplicate them, move them downwards to my setup 5. The pocket needs to be recalculated. We can do this by Ctrl G. And now let's go step by step. The trace, what he needs is the new geometry. So these ones here, click OK, and this is done. For the face, we simply have to regenerate and it switches to the top side here. For the pocket, we do a little bit more. We need to change the group here where we set avoidance. So let me select this from the beginning again. Let's make the sketches invisible so it's easier to click here. The desired geometries we want to avoid. Once they are selected, so the last one down here, we set this to OK. But for the height tab, we want to go maybe -13, but it might need to be adjusted. And the stock to leave, wait, I was too fast now. Let's go in there again. The stock to leave, I want to set to a normal value, not this odd value like before. I want to set it to plus 0.1 millimeters. While this is generating, we can also go already to the next one. The next one is a flat operation. We just need to generate it. And the ramp function, what we want to change is in the heights again, let's say -13, but we need to evaluate this before we actually start milling this. Stock to leave I remove here. And the other ramp, it's basically the same. It was our ramp that just recuts the same geometry with just a little bit of a higher step down. So let's put this to -13 as a placeholder. Let's see if we can really use it. Stock to leave, remove. And this is also generating. So lastly, these 3 operations for deburring the edges. Sure, we need to select the correct geometry, which we have done here. And for passes, we will set it to 0.2 because we have not undercut action happening on this side. The next one, we also need to choose the correct geometry again. So it's these edges here. Let's click them one by one. having a little bit difficulty hitting the edges here. And once we have selected all of them, we press OK. Let's check just the bases. Bases still looks good. Yeah, that looks fine. And then we repeat this for the last operation here. Geometries, select these edges one more time. And then the setup 5 should also be ready to be executed. And again, we will tranche this in different sections. So let's simulate quickly what we have created. So before that, I want just to make sure that we mark this operation and the ramp operation with adjust height. There is a potential that we need to adjust the height, but it highly depends on raw material and unevenness of the machine and other factors. So, like I said, let's now simulate the first operation here, or the first setup, sorry. What we do is we cut into the cutting board. Don't be worried about these collisions here. It will give us collisions, but while we are doing these holes, the aluminum plate will not be placed. The setup 4 is just preparing the fixture holes. So it will cut here like we have done in our very first setup 1. Lastly, let's check setup 5. I will go pretty fast over this, just show you what we are doing. So our trace, then our facing, then we have our pocket, then we have our flattening, then our ramp and another ramp, and then it's our deburring with the engraving tool. So we are ready to do a bunch of milling because we have now done a bunch of programming. We are at the machine, starting with cutting the holes in the CNC cutting board. I first get a reference from the board itself. By referencing there, we go 100 millimeters up and 0. We start the setup 3 underline A and cut these holes. Once they are cut, we can check if the dowel pins already fit. If they don't fit, we increase the diameter a little bit and repeat this process again. But in my case, fitting the dowel pins on the first try already worked, and I could go on continuing with placing the dowel pins inside the aluminum plate. The threads are looking in our direction. Then let's mount it into the machine and use the fixtures to mount it and secure it. Once it's secured, we can go again to the same 0 point as before and trigger our setup 4 underline A. This will cut our fixturing holes that we will use for the remainder of these milling processes, and also later when we are actively using this subplate as our base plate to mill other parts on. So it's done. I clean it real quickly and secure it with my screws and remove the fixtures in the middle. Now we need to get a new reference from the top of this subplate. Get my reference again with the filler gouges. Once having found it, I will go 100 up plus an additional 2 millimeters, and you already know this drill. We try to find the surface, the first contact, which we will do with setup 5 underline A. We will continuously going down in 0.02 millimeter steps till we make the first contact. Like we see here in this corner, we have the first contact. We will then go to the next setup, next setup section I need to specify, the setup 5B, which is the facing operation. Didn't catch everything in this first run, so I run it again and again till I see that everything on this surface has been touched by this operation. Now it's time to make a measurement. I set the caliper to 13.3. I check two things. First, do I touch the cutting board? And second, am I going deep enough to go under our undercut that we did on the first side? If both statements for all the four corners are true, we don't need to change something in the fusion and can run the setup 5C as it is. If you don't have enough distance to the cutting board, for example, in your measurement, you would need to adapt the three operations that we marked with adjust height. So this section is also nearly done, and as you can see, we can create really good results, and we will finish this up by deburring the edges, which will be our last setup. That is called setup 5 underline D. Now it's time to remove the subplate, and I will show you the trick with the M8 threads. We can use them to kind of lift the subplate from the CNC cutting board. Makes it easier for us to remove and mount it back on again. So this sums up the process of producing your own subplate for your Snapmaker Artisan. I hope you learned a lot. I hope it was explained well enough. I'm eager to hear and get some feedback. And lastly, I want to mention that I'm running now coupon codes for Snapmaker. So anyone interested in buying a Snapmaker Artisan or already having a Snapmaker Artisan and wants to extend it with some modules can now use the code MiWiCNC to save 5%. Thank you for watching till the end. I see you in the next one. Bye.